Welcome to the Chemistry, Biology and Math Revision Hub. This video is part of the Chemistry Topics Revision series, and today we are looking at electrolysis. Electrolysis in aqueous as well as in molten. Molten meaning liquids that have been melted, and in aqueous meaning there is water involved, so it's a solution. So let's begin. So we'll begin by looking at the general definitions. Electrolysis is a chemical change caused by passing an electric current through a compound that is in molten or aqueous state. So when an electric current is passed through, electrons are going to move and electrolysis will occur. When we carry out electrolysis, we need a liquid. It could be a liquid which could be in a solution or just a liquid. So this is what we call an electrolyte. Electrolytes are liquid or solution that undergoes electrolysis. To do that, so this one here is the electrolyte. You can see this one here, the molten electrolyte. And this one, as well as that one, are the electrodes. So electrodes are terminals through which electricity is passed to and out of the electrolyte. So basically, electricity go through, or the electrons flow through the electrodes. The next part, we're going to talk about the cathode. The cathode is where reduction occurs. The electrode that carries out reduction, or where reduction occurs, that is the cathode. And the anode is the electrode where oxidation will occur. Oxidation is loss of electrons. So the electrode where electrons will be lost is the anode, and the electrons where the electrode where electrons will go to is the cathode. Reduction is gain of electrons. Remember this. It reminds you of that. And oxidation is loss of electrons. So you can remember by saying oxidation is loss of electrons, and here reduction is gain of electrons. A reducing agent is a substance that gets oxidized. So it's a reducing agent because it causes something else to be reduced, but it itself gets oxidized. An oxidizing agent causes something else to be oxidized, so it means it's the substance that gets reduced during a redox reaction. And finally, among the definitions, a redox reaction is a reaction in which oxidation and reduction are involved. Remember, we are calling it redox, meaning there is reduction here and there is oxidation combining. So if there is an overall equation where reduction is occurring and oxidation is occurring, we call that a redox reaction. This is an example of a setup that would be seen during electrolysis. We can see there is this electrode, that electrode, there is this electrolyte, there is of course this trough that is containing the electrolyte, and then we have the positive and the negative showing electricity has been connected. Examples of reactions. Remember I said reduction is when electrons are gained. So these are examples of reduction reactions where lead 2 plus gains 2 electrons to become lead solid. And here we can see sodium plus gains 1 electron to become sodium. This is in solid state. Examples of oxidation reactions. I said oxidation is loss of electrons. So if we have O2 minus loses 2 electrons, because these are 2, they lose, each loses 1 electron, so total 2 electrons are lost, they become oxygen. Or 2 bromides lose 2 electrons to become bromine. These are examples of our oxidation equations. So let's move on. We'll begin by looking at electrolysis in molten. Remember, molten means something has been melted, so there is no water here. It means if it's sodium chloride, you will only have sodium cation and chloride anion, nothing else, because these are the only ions involved in that specific liquid. So here we will set up, in here we will have sodium plus ions and chloride minus ions. However, since the sodiums are positively charged, they'll be attracted to the negative electrode, while the chlorides that are negatively charged will be attracted to the positive electrode. So here he said, the ionic substance is heated until it melts. So you will get sodium chloride heated until it melts. When it melts, the ions are free in the electrolyte. I would say electrolyte liquid, not solution, in the electrolyte liquid. And then the power is connected to make the electrodes charged. This power is going to cause these electrodes to be charged so that the ions in that liquid go towards the oppositely charged electrodes. So products like gases are deposited, formed, and then the positive ion in the solution, also in the liquid, because this is molten. So the positive ion in the liquid are drawn to the negative electrode, and the negative ions are drawn to the positive electrode. reactions occur at those specific electrodes, and then some things are going to be formed. Either we're going to form gases or we're going to form some ions. So gases, or we form some solids, some solids. So let's begin. Let's continue. Going back here for sodium chloride, let me write for you some examples. So for sodium chloride, since if we have this as a positive electrode and this one as a negative electrode, the sodium is going to be attracted here and the chloride will be attracted here. So we will form chlorine at this side because that's where chloride was attracted. And on this side here, we are going to form sodium solid. So sodium will be deposited around here and the chlorine gas will come off around here. So that is how it will look like. Further explaining about electrolysis in aqueous solution. For aqueous solution, it's a different story because we have so many ions in the solution. Let's take an example of sodium chloride solution. In there, we will have sodium plus ion, chloride minus ion. So these two from sodium chloride. But because it's an aqueous solution, there is water. So we will have H plus from water and OH minus from water. So there is a competition between sodium and hydrogen ion. Which one will go to the negative electrode? There is also a competition among these for the positive electrode. So one ion is going to be preferred here, and the other side also one ion will be preferred. So we're going to look at the rules or the facts that we have to consider to see which ions are going to be preferred on which electrode. So the first thing we need to see is 1, metal higher than hydrogen in the reactivity series. If that is the case, then hydrogen gas is formed at the cathode. Remember, the reaction that occurs at the cathode is reduction, and it means that reactivity series is a series of reactions. So reactivity decreases as you go down, but that kind of reactivity is the ability for them to lose electrons, not the ability for them to gain electrons. So it means those that are below hydrogen are better at gaining electrons than hydrogen, so they will be formed easily at this electrode. So here we say a metal higher than hydrogen in the reactivity series, hydrogen gas is formed at the cathode. So in this case, hydrogen is going to be preferred as that's the first rule. The next part, if there is a metal lower than hydrogen in the reactivity series, the metal forms at the cathode. So for this case, these ones here, their metals will be formed at the cathode because they're lower than hydrogen in the reactivity series. Moving on, if solutions of halides are used, halogens are formed. So because here we have a halide is always preferred, and therefore a halogen will be formed at the positive electrode. So here we're going to see solutions of complexes like sulfate, nitrate, or hydroxide, and so on. Oxygen from the ionization of water will be obtained at the anode. So for these polyatomic anions, it's always going to be oxygen that is preferred. So remember, you have to know the reactivity series in order to know which one is going to be better or which one is going to be preferred at which electrode. So let's move on. We're going to look at the example of copper 2 sulfate solution. Remember, in copper 2 sulfate solution, we'll have copper 2 plus, we'll have SO4, 2 minus, and then we'll have H plus, and of course, we're going to have OH minus. If we go back to the reactivity series, you can see that copper is below hydrogen, so it means it's going to be preferred at the negative electrode. So here we see, if this is going to be the negative electrode, you can see that, and that is the positive electrode. Copper is deposited at this negative electrode because copper 2 plus ions were preferred. And remember, initially we had copper 2 plus solution, which is going to be blue due to copper 2. But as the copper forms here, you can see the color of copper solid is observed at that specific electrode. Now it means among these two, copper was preferred at the negative electrode. Looking at the anions, since both of them are polyatomic, it's going to be oxygen that is going to be formed at the positive electrode. And here we can see bubbles of oxygen gas being formed. So here we read the positive ions, copper 2 plus and H plus, move towards the negative electrode, and then the negative ions that and that move towards the positive electrode. However, reactions that occur at the positive electrode, we can see the OH minus forms water, oxygen, and 4 electrons. So oxygen gas is going to be evolved. And at the negative electrode, copper is going to gain 2 electrons, forming copper solid. So the solid of copper is deposited at that electrode. Let's move on to the next part. This is a summary. We have to know whatever we're dealing with, if it's a solution or if it's a molten ion. So basically, if they're molten ions, it's really easy to predict. The negative goes to the positive electrode, and the positive will go to the negative electrode. However, if the ions are in solution, it means we have so many ions, and the preference or the rules have to be followed in order to predict which one is going to be formed at a specific electrode. So for sodium chloride solution, remember we will have those and we will have those. However, these two positives are competing, and you know sodium is above hydrogen in the reactivity series, so hydrogen gas is going to be formed at that specific electrode. You can see here the cathode hydrogen gas is formed, and then at the anode we have a halogen, so the halogens are always preferred. That is why you see halogen gas is formed, in this case chlorine. Now with copper 2 sulfate, we have copper 2 and that competing. Copper is below hydrogen, so copper is going to be formed. And here we can see these are polyatomic, so oxygen is going to be formed. You have to remember how to write these equations. So here we see oxygen formed at the anode, and then here we see copper solid deposited at the cathode. Let's continue. With magnesium bromide, we have magnesium 2 plus competing with hydrogen, but magnesium is higher than hydrogen, so hydrogen gas is evolved at the cathode. And then here we can see these two, there is a halide ion, so the halogen is going to be formed, which is bromine evolved at the anode. Lastly, let's look at this. Here we have sulfuric acid and water. Of course, there is going to be H plus and H plus, so here it's hydrogen that is going to be formed at the cathode. However, on the other hand, it's going to be oxygen formed at the anode due to the rules we have followed previously. So I think this brings us to the end of this part. Remember, we have looked at electrolysis of molten ions as well as electrolysis of aqueous solutions. The electrolysis of molten ions is really easy to predict because you are dealing with only 2 ions. However, electrolysis in aqueous solution, you have many ions, so you have to follow specific rules to predict which is going to be formed at which electrode. This brings us to the end of this video. Thank you for watching, everybody. Please do not forget to subscribe to our channel. I'll see you in the next video. Bye-bye.